Alright, let's dive into something that completely blew my mind recently. Did you know that earthquake sensors can actually reveal the strongest part of a hurricane? Yeah, I was just as surprised as you probably are right now. Here's the deal. Back in 2012, Hurricane Isaac was making its way across the Louisiana coast, and while it was doing that, it was literally pushing the ground down and pulling it back up. We're talking about movements so tiny, a fraction of a millimeter over about 100 seconds, that no one standing there would have felt a thing. But here's where it gets wild. Seismometers, those instruments designed to study earthquakes, picked up the entire event. And years later, researchers found something incredible in those records: the calm eye of the storm and the wall of wind surrounding it. What makes this really interesting is that the lowest part of a hurricane, the boundary layer, is the hardest to measure. This is the layer closest to the ground where wind, heat, and moisture mix together, and it's this layer that determines whether a storm strengthens or weakens before it hits land. Traditionally, measuring this layer has been a nightmare. You've got government crews flying into storms, dropping sensors, and dealing with dangerous conditions. Buoys and wind towers only give you surface-level data, and radar? It's just snapshots. So, when researchers realized that seismometers and low-frequency microphones could do the job, it was a game-changer. Personally, I think this is a perfect example of how science often finds solutions in the most unexpected places. These seismometers weren't even placed there to study hurricanes. They were part of a project to map the inside of the planet. But because Hurricane Isaac happened to cross over them, we got this incredible insight. It's like the universe handed us a gift we didn't even know we needed. Now, let's talk about why this matters. Hurricanes are massive, spanning 300 to 400 miles, and they rotate around a calm, low-pressure center. The eyewall, this ring of intense wind and rain, is where the action is. But it's the boundary layer that's the real star of the show. How vigorously this layer mixes is one of the main factors that determines a storm's strength. Forecasters need this data to predict how a storm will behave, but collecting it has always been a challenge. What many people don't realize is that hurricanes create pressure fluctuations that push and pull the ground, generating seismic signals. Initially, researchers thought these signals would be too chaotic to interpret, assuming that a storm's seismic waves would come from all directions at once. But Qing and Eric Dunham from the Stanford Doerr School of Sustainability found something different. Each seismometer was actually responding to conditions almost directly overhead, meaning they were capturing local turbulence rather than a broad average. This shifted their focus to the boundary layer, and that's where the magic happened. A detail I find fascinating is how they used microphones to record infrasound, sounds too low for humans to hear, to track pressure swings in the boundary layer. By comparing these records with the seismic data, they could watch the storm's eye pass over individual stations, with the eyewall arriving before and after it. And the best part? The data matched closely with measurements collected using conventional methods. This isn't just a cool experiment. It's a new way to study hurricanes that could make forecasting safer and more accurate. If you take a step back and think about it, this research opens up so many possibilities. We've only seen this applied to a Category 1 storm like Isaac, but what about a Category 5? A stronger storm should produce a larger signal, and that could give us even more detailed insights. The Stanford team is already planning to analyze other hurricanes, and G wants to equip existing stations to serve both seismic and atmospheric purposes. It's like killing two birds with one stone, or in this case, two scientific goals with one set of sensors. This raises a deeper question. How many other natural phenomena are we missing because we're not looking in the right places? Science is full of these moments where someone says, "What if we try this?" and it leads to a breakthrough. It's a reminder that innovation often comes from connecting the dots between seemingly unrelated fields. So here's my closing thought. This study isn't just about hurricanes or seismometers. It's about the power of curiosity and the unexpected ways we can learn about our world. What other hidden patterns are out there, waiting for us to find them? Let me know what you think in the comments. Are there other areas of science where you've seen this kind of cross-disciplinary magic happen? And if you enjoyed this deep dive, don't forget to hit that like button and subscribe for more. Let's keep exploring together.